Hello and welcome back to Quay Does Leetcode. Today I'm doing problem number 211, design and add search words data structure. Design, add, and search words data structure. So for this problem, you need to design a data structure that supports adding new words and finding if a string matches any previously added string. So it can you implement the word dictionary class, and you have three functions for it. You initialize it, and you add a word, and then you search a word. And there's one particular thing that you can do for searching a word that makes this problem a little tricky. So if when you search a word, you return true if there's a string in the data structure that matches the word, or false otherwise, but the word may contain dots, where dots can be matched with any letter. So let's look at the example. So you have a new word dictionary, and then you add bad to the dictionary, and you add dad to the dictionary, or not the word dictionary, and you add mad. Then you search, is pad in there? No, pad's not in there, so you return false. Is bad in there? Yes, bad's in there, so you return true. Now here's the tricky part. Is there a dot AD, meaning any letter, and AD? Yes, there's bad and dad and mad, and so you return true. And now, is there a B, any letter, and any letter? So there's a B, and then there's A, could be matched with any letter, and a D, which could be matched with any letter. So that returns true. So for this problem, we're going to use a try data structure, because a try or a prefix tree helps you to determine if there are words that match a particular prefix, and you can see how that would be helpful for this problem. So we're going to use a try data structure. So let's draw out what this would look like with using a try data structure. So let's add this. So for a try, you have a root node, and then you have children. So we're going to add bad. So the first child is going to be a B, and this B is going to have a child of A, and it's going to have a child of D. Now we're going to add a dad. We're going to add dad. So there's no node that starts with a D yet, so we're going to add D, A, D. Now we're going to add mad, M, A, D. Okay, so now we're going to search pad. Is pad in there? Well, we're looking for P. This is not P, this is not P, this is not P. So pad is not in there, so return false. Bad, we're going to look for bad. Oh, and we're going to indicate that these are the ends of words here. So we're going to look for bad. So we start, is there something, a B that is in the first position? Is there, yes. Is there an A? Yes. Is there a D? Yes. Is it the end of the word? Yes. So this is true. And now is there a dot, A, D. So we can go along any of these nodes. So this dot means we can go along any of these nodes. So we're going to have to go along each of these nodes. So we go to this node and we say, okay, is there a, if after that node, is there an A? And after it, is there a D? Yes. So automatically we return true because we found it in the first try, but we could have had to try all of these first nodes, and then we would have returned. We would have had to check them if we didn't return true here, but now we're going to check a B, a dot. So so for this B, we see that there's a B. Now we check for this B. Is there any child? Is there any child that does this B have any child at all? And it does. So that's yes. And does that child, does that have any child at all? And it does. So and is it an end of a word? Yes. So we return true. So in order to check if any of the things match, we're going to have to go through all of the children, and we're going to have to use backtracking for that, but we'll see it in the code. It's a little tricky to implement checking every single letter, every single child, to see if it matches. So let's move to the code. So first thing we're going to need is we're going to need a try node. So this wasn't here, so I can just add that, a try node class, and we're going to make an init function for it. And if you know about a try, you know that it needs basically two things for this try node. We need self.children, which is going to be implemented as a hash map where the key is the letter and the value is the node. And then we're going to have another variable to keep track of whether or not this is the end of a word. And we're going to set this to false by default. And now we're going to make our word dictionary class, and we're going to make a root node, self.root equals a new try node, empty try node. And now we're going to write our function for adding a word. So to add a word, we're going to start at the root. So we're going to have a pointer that starts at the root. So current is equal to self.root. And we're going to loop over all of the characters in word. So for char in word. And then we're going to check if the character is a child, no, is a child of the current pointer. So if char not in current dot children, then if it's not in there, then we're going to need to add it. I'm sorry. We're going to need to add it. So we're going to add a current dot children at char is going to be equal to a new try node. And then we're going to update our current pointer to be equal to current dot children at char. So if it was in there, if the node was already there, because we don't want to add a node if it's already there. We don't want to have duplicate nodes. So, but if the node is already there, then we just move our pointer to the next node, to that node. And then at the end, we just update our current pointer is going to be at the last node in the word. So we update current dot end of word to be equal to true. Now here comes the tricky part. So now we're going to implement the search function. So the easiest part to implement is if the character is not a dot. So let's try that. So we're gonna say current. We're gonna start at current again, current, and start at the root. So equals self dot root, and then we're going to loop over the word, but instead of using the character, we're going to actually use the index. So and you'll see why when we get further down in the code, we're going to do for I in range length of the word, and we're going to say character equals word at I, and if character equals a dot, then we're going to do something, but we're going to leave that off. So we're going to handle the easiest case first, which is the else case. If the character is not a dot, then the character is a letter. So we're going to check if char not in current dot children, then we're going to return false, and our current is going to be we're going to update our current to be equal to current dot children at char, and then we're going to at the end we're going to return current dot end of word. So that's if the letter is a letter and not a dot. If it's a dot, well then we're going to need to loop over the children for children in current dot children dot values. We're going to need to loop over the children, and we're going to need to do a backtracking. So we're going to need to do a depth first search. So we're going to so what are we going to need to do? We're going to need to do a depth first search for every single child, and we're going to need to check if that child is qualifies as it qualifies as a node. So for that, so what we've been doing is we've been actually writing this step first search. So we're actually going to be recursively, this is the recursive function. So we're going to add a recursive function. We're going to indent this. We're going to define a depth first search and give it a root and an index. We're going to call it J, and we're going to indent this over. So we're going to say if depth first search of this child returns true, then we return true. Otherwise, if it goes through the entire thing, all the children, and none of the children match, then we return false. And we also need to pass it an index. So what index are we going to pass it? Well, for each child, we're going to be going in one index. So we're going to, so if we were here, if we were here, then we want to actually return, we want to loop through the next index. So we're going to give it I plus 1, because we want to check is the next child of what is the next child of our current child qualified as the word or not. So it's going to match yes if it is actually a letter that matches, or it's going to match if it is a any child matches. So we're going to return, so we're going to pass that I plus 1, and we also need to change this to start from, instead of starting from 0, we need to start this from actually J. So we start this from J, and instead of passing it self.root, we pass it root. And then at the end we return, so we call this function depth first search, and we pass it self.root, and 0 is the first index. And then that should be it. So let's run this. This should be for child, and we're not getting the right answer. We need to move this to be outside of the for loop, because we need to finish the for loop, and if that is the end of word, then we return true. Otherwise, if it's not the end of word, we return false. And there we go, getting the right answer now. And now let's submit. and it was accepted. So that is how you solve this problem. Yeah, it's pretty efficient using a try. And thanks for watching. I'll see you in the next video.